Assalamu alaikum, students. As you know, because of the coronavirus, we are going to start the online lecture. So, first of all, let's review the course outline. Before the midterm exam, we study chapter 8, that was about the exergy analysis, chapter 9 about the gas power cycle, chapter 10 about the vapor and combined power cycle, and for the post midterm, we'll try to cover chapter 11 to chapter 15. Right, let's continue with chapter 11. Right, chapter 11 is about the refrigeration cycle. In this chapter, we'll learn about the fundamental theory related to the refrigeration cycle, and we'll try to analyze different aspect of refrigeration. So let's start with the definition. What is refrigeration? Right, we can define refrigeration as the process of producing and maintaining low temperature within a confined space lower than the temperature of the surrounding up to the target temperature. We may define refrigeration as refrigeration means the continuous extraction of heat from a body whose temperature is already below the temperature of the surrounding. So as you know from the second law of thermodynamics, we can lower the body then the environment temperature, but we need to put certain input. We cannot violate second law of thermodynamics. In case of refrigeration system, we give certain electric input to the refrigeration system, or sometimes we give heat input to the refrigeration system. Basically, we'll see in the coming lectures that basically the refrigeration system can be based on the electric system. The major input is the electricity, or sometimes the major electricity is heat. So we'll study that in details. And then how can we define the units of refrigeration? The capacity of the refrigeration. Just like we studied in previous chapter, let's say we had a boiling process. So what is the capacity of a boiler? So we define the capacity of a boiler as TPH. 60 TPH mean 60 ton of steam produced per hour, TPH, right? Similarly, we have certain units of refrigeration, and the units of the refrigeration is ton of refrigeration. What is the physical meaning of the ton of refrigeration? That's the amount of the heat extracted, right, by the refrigeration or air conditioning equipment, and numerically we can define as the rate of heat removal required to freeze a metric ton, 1000 kg of water at 0 degrees centigrade in 24 hours. So then that capacity of the refrigeration will be equal to 1 ton of refrigeration. To understand this, let's say we have water here, let's say water, and that water is, let's say, 1000 kg, right? The water is 1000 kg, and that's at 0 degree centigrade, right? So if we convert this 1000 kg of water into ice, solid ice, at 0 degree centigrade, now you can see this is basically a phase change process from liquid water to solid ice, right? For liquid water to solid ice. If this process take place in 24 hours, then we'll say the capacity of the refrigeration unit is 1 ton of refrigeration. So that means by converting 1000 kg of water at 0 degree centigrade to ice at 0 degree centigrade, and if the time takes in 24 hours, then the capacity is equal to 1 ton of refrigeration. So, but normally we define capacity in heat extraction capacity we define in terms of kilowatt or kilojoule per second. So we can convert basically this ton of refrigeration into kilowatt or kilojoule per second. How? Now, we know the latent heat of the ice, which is also called heat of fusion, that's equal to 335 kilojoule per kg. And for this is for 1 kg, and for 1000 it will be multiplied. So let's say that's in 24 hours. We can convert this into, let's say, kilojoule per minute. We have to divide with 24 and then with 60, so that will be kilojoule per minute. So that means 1 ton of refrigeration is equal to 233 kilojoule per minute. We can also convert it into, this is basically kilojoule per second. If we further divide this 233 with the 60, then you will get the unit 3.876 kilowatt. So basically 1 ton of refrigeration is the heat removal capacity equal to 3.876 kilojoule per second or kilowatt. Actually the experimental value is a slightly lower, right? So all are agree on this numerical value that 1 ton of refrigeration is approximately equal to 3.5 kilowatt. So as this is the heat extraction capacity, so we can define tons of refrigeration in terms of the heat removal capacity of that equipment. Now the question comes, is there any difference between the refrigeration and air conditioning? Yes, there is difference. In case of air conditioning, the objective is to produce the human comfort. And in human comfort, it comes the temperature, control of temperature, humidity control, smell control, noise control, right? So the objective is to produce human comfort. But in case of refrigeration, the objective is to produce the low temperature. But the capacity of the refrigeration and air conditioning unit both will be defined in terms of tons of refrigeration. Now, next question comes, what are the methods available for producing refrigeration effect or producing low temperature? So these are the following methods by which we can produce the low temperature. One of them is sensible cooling by cold medium, phase change process, endothermic mixing of substance, expansion of liquid, expansion of gases, thermoelectric refrigeration. Now let's discuss one by one. First one is sensible cooling by cold medium. As the name suggests, this is derived from the sensible heat. In case of sensible heat, that's the transfer of the heat by the difference of temperature. I mean, you have one hot body and another is the cold body. So once these two objects are brought into contact, in thermal contact, then the heat will transfer from hot body to the cold body. So as a result, the hot body can be cooled down with the help of cold body. So that's called the sensible cooling by a cold medium. Now the practical example is the air conditioning process. I mean, let's say if we have a building, right? Let's say this is our building, and let's say during summer the temperature is 30 degrees C, right? And the conditioned air temperature is, let's say, 20 degrees C, right? 20 degrees C. So once that air will move into the building, that it will absorb heat from the room, and then the outlet temperature will be of the air condition will be higher than the inlet temperature. And how can we calculate that heat extracted capacity? So that heat extracted capacity will be basically can be converted into tons of refrigeration. Like we can calculate with the help of this formula. Like the heat absorbed from that room is equal to mCp delta T, where delta T is the difference of the temperature between inlet and outlet, and mass flow rate of the air, Cp, the specific heat of the air, right? And the second method is the phase change process. We can also produce cooling with the help of phase change process. Now there are different phase change process. You are familiar with that: sublimation, melting, and evaporation. In case of sublimation, solid directly convert into gas phase, whereas in case of melting, solid is converted into liquid, just like our ice. If ice is solid, it will melt and it will transfer into liquid. In evaporation, a liquid is converted into vapors. So in all these, phase change process can be used to produce cooling, right? For example, you might observe during the snow falling. Once the snow falling is finished, then after certain time, if the snow start melting, then it will absorb heat from the surrounding. As a result, the surrounding temperature will fall. So that means in the surrounding, it can produce cooling, and this solid snow will be melted, right? So that's a phase change process at constant temperature. Similarly, example of the pure ice. So let's say at atmospheric temperature, if we place our ice cube here, then with the passage of time, the ice cube will start melting. Why it is melting? Because it is absorbing heat from the surrounding, right? So and the surrounding temperature will decrease, but the temperature of the cube will remain at 0 degree centigrade. And similarly, the part of the ice which is melted and converted into liquid, let's say water, the temperature will remain at 0 degree centigrade until the whole ice is melted, right? So that's a phase change process. So we can also produce cooling by using phase change process. Similarly, we have the example of the sublimation. Let's say we have a solid, let's say dry ice. We also call this solid carbon dioxide. So when it goes sublimation at a temperature of minus 78.5 degrees centigrade, again it gives a refrigeration effect of 573 kilojoule per kg. And what about in our refrigeration system, our local refrigeration system? We use the evaporation, because evaporation is again a phase change process. For example, how in our common refrigeration the cooling effect is produced. Let's say there is one of the compartment, we say evaporator. Let's say this is an evaporator where we place our items, let's say milk, meat, vegetables, right? These are the things that we place in the evaporator. So what is happening in the evaporator? Basically the refrigerant enters into the evaporator in liquid form. So that's a liquid refrigerant. So through the tubing it moves into the evaporator, and then when it leaves from the evaporator, the phase of the refrigerant from liquid, it is changed into vapor or gaseous phase, but the temperature remains constant. So what is happening? The items which is placed inside the refrigerator, its temperature is higher. So what will happen? This refrigerant inside the tube, it will absorb heat from these items. So the heat from these items will be absorbed by the refrigerant. So as a result, the liquid refrigerant will be converted into gas refrigerant. So that's again a phase change process. So with the help of this, we can produce a cooling effect. And how can we calculate again that how much heat is absorbed by this liquid refrigerant? Now this is a phase change process. So in case of phase change process, we have to use again Q is equal to M delta H pH. Now this is the enthalpy of the phase change. It depends on the process. If the process is a sublimation, that's enthalpy of the sublimation. If it's evaporation, enthalpy of the evaporation. If it's melting, then enthalpy of the fusion. So in this way we can calculate how much heat is absorbed by the phase change process. So as a result, we can also produce cooling with the help of phase change process.